Today we're going to look at an algebra problem with polynomials. Here we try to find the coefficient of x squared term when you expand the product of these certain terms. How would you solve this? Now the brute force approach is where we're going to look at the expansion and consider all possible ways that can generate the x squared terms. So we have a bunch of binomials. How to get x squared term? There are two possibilities. One is that the x term of one binomial here multiply by the x term of another one. For example, this along with 2x, negative 1x, 2x, that would produce negative 2x squared. You're going to consider all possible combination. It's also possible for the constant term, like 1, with some other term where there's x squared, but here we do not have it because we only have linear term here, right? There's no quadratics, all right? So we only need to consider the first case. If you have two terms, 1 plus ax and 1 plus bx, then the x squared coefficient would be a times b, just the product of the linear coefficient here, right? So we're going to consider all possible pairs here, the certain terms, the certain choose two pairs. If you visualize this relationship, you're going to say this is the term negative 1 plus 2 minus 3 plus 4 minus 5, so on and so forth until negative 13. You do pairwise products and then you sum it up. All right. So I did the math. Actually, I'm cheating. I did not do the math. The answer is negative 385. Because I'm lazy, I don't want to actually brute force it. If you know Python, you can actually try to write a simple program for the coefficient here. You do a for loop to figure out the pairwise sum, and then you print out the results. I run that is negative 385. However, that's not the point for today's video. The preferred way is always not the brute force one. For this x squared term, we need to do the pairwise sum. But for the pairwise sum, there's a useful identity, and that's actually common in some competitive math. Here is the useful identity. That is, for n numbers, the sum of pairwise product is equal half of the square of the sum minus the sum of square. You have probably seen the identity for the case where n equals 3. So here the pairwise sum equal half of the square of the sum minus the sum of squares. You can verify this identity. It is also useful to recall that the sum of square formula for integer from 1 to n is given by this formula. We're going to use that. Back to our problem. So we have coefficient negative 1, 2, negative 3, 4, and negative 13. And the sum, right, if you add it up, and the sum of squares, you plug in the formula here, right? And then you could get the answer. That's easier than the brute force one. So I hope you appreciate the trick here. Now for this and other interesting math problems, please like, share, and subscribe to the channel.